Engine Performance 1, Test 9. Engine Performance 1, Test 9. Computers and Networks, Onboard Diagnostics, from chapters 18 and 19 of Halderman's textbook there. The ratio of on time relative to the period of the complete cycle is the,
Frequency, not duty cycle.
what is it?
Duty cycle.
That's the duty cycle. So basically, have you ever heard about a welding machine having a duty cycle?
Yeah.
That's how long that you're allowed to weld with it. In other words, how much cooling it has to have versus how much welding time it's got. These little Lincoln cracker boxes like the one we got over here, has got about like 20% duty cycle. So you gotta give it 8 minutes of cooling for every 2 minutes of welding on the average.
Hey,
Hey,
I got a flat tire on my truck and I wonder if we can fix it.
yeah, there'll be 3 flats we fixed today in the road. Yeah,
I got a big nail on
okay, big nail in it? Well, leave it out there and leave the key in it and come back and see us in a couple hours.
it. It's a blue Nissan truck.
You got it parked right out here?
Yeah.
Okay, all right.
Thank you.
Yes, sir. Which data set contains only 2 digits?
Binary.
Is that right, y'all? You like that?
Yeah, 0 and 1.
Yeah, binary. What are the 2 digits that it contains?
0 and 1.
0 and 1. Very good, Joe.
1 0 1 0 1 1.
You remember when I did that last semester, binary math? You remember the binary math, how it works? Remember how binary math works?
Yes.
Huh?
Yes.
Binary math. I had this little old girl over here one time, Christina, and I was flipping some dip switches on a little board that I was putting in his computer. And that's what, you know, you've seen little dip switches where you got a whole bank of them there and you got to turn some of them on, some of them off? I mean, that's what that's basically about. They're little switches on a computer board, like when you're setting things up. Anyway, that's a binary code thing. And somebody said, what's that binary code? She goes, I can show it to you. And she got up here and drew it all out on the board real quick. I mean, I hadn't even taught her that yet, but she knew it. Which computer function is defined as a voltage signal from a sensor or switch?
Output.
Now listen to what, did you read the question?
No.
Which computer function is defined as a voltage signal from a sensor or switch?
Input.
Input. It cannot be an output if it's coming from a sensor or switch. Which computer function describes how the computer handles inputs?
Outputs. Or process. Process.
Yeah, you're basically going to process. As a matter of fact, on the engine controllers at Ford they used to call them processors. That's what they used to call them. Now they call everything a PCM. When is it not called a PCM?
What is it not?
Yeah, there are times, even on today's vehicles, when the engine controller, is not called a PCM.
Adam might call me ACU. I don't know. What is
Well,
that?
that's the audio control module there, but
Yeah, what is that? I don't know.
yeah, when is when the computer that runs the engine, is not called a PCM, when is it?
It's an ECM.
I mean, but why is it sometimes called an ECM instead of a PCM? There's a reason for that.
Is it because it doesn't have
Yeah.
a ECM?
It's only controlling the engine, not the transmission. Got me? Okay. All right. Okay.
You know gonna do what?
Which computer component generates a steady stream of 1-bit long voltage pulses?
Capacitor.
You're just talking off the top of your head there, aren't you? Just
Probably.
poof,
I
just
don't know
just
a lot
guess,
about
pulling them out of the air and all that
Central
kind of stuff.
processing unit.
Yeah. Yeah,
I don't know a
so,
lot about
yeah.
computers at all.
if you think you know the answer, that's one thing. If you're just taking a wild guess, that's basically throwing
Well,
words up in the
first
air.
two I didn't know.
So,
Yeah.
C.
What is it? It's a,
Central processing unit.
No, it's a clock generator.
Is it what?
Clock generator. Which term describes the process of manually adjusting variables such as speed, load, and spark timing to determine the optimum output settings for the computer?
Performance program?
Reflashing.
Huh?
I say reflashing.
No.
Signal conditioning.
What about it, Quincy?
Well, I'm gonna go with,
Where are you gonna go? Give me an idea. Which term describes the process of manually adjusting variables such as speed, load, and spark timing to determine the optimum output settings for the computer? Okay, what if you were gonna decide, huh? What'd you say?
end of that.
He's right. Give that man a cigar,
If I had
a
one-
chocolate cigar, or a
Oh, man,
bubblegum
that's a
cigar.
cigar.
All right, okay, very good, yeah. But imagine your computer has got a deck of cards. And every particular card is only suitable for one particular set of operating conditions. You know what I mean? Now, they have, and these are called, these little cards that I'm talking about are actually cubes, you know, but they're called they're called cells. And there are significant cells that are specifically referred to as purge-free cells. Alex, you know what purge is? Anybody know what purge is?
It's where it
Things that you
forces
take.
pressure, right?
Huh?
I mean, you, discard.
The canister, no, well, basically a canister purge is what we're talking about.
Okay.
Because when it's purging the canister, what does it need to factor in? Hydrocarbons. If you're purging, you're going to have to factor in the fact that there's going to be an unknown number of hydrocarbons coming in there that are within a certain window. If there's too many hydrocarbons coming in, like if you've saturated your canister, it's going to cause it to run too rich. But basically, you're basically going to go, and even in some of your scan tools, like the DRB3 scan tool that the Chrysler uses, if you've got a failure, basically, that thing is designed to store what they call a similar conditions window. So when this code was stored, you can find your freeze frame. You know what freeze frame is? Everybody know what freeze frame is? This is your performance class. What's freeze frame? What's freeze frame data? You know?
It's like a picture of what happened.
It just stops everything.
You know, carry that word to its logical conclusion. Well, no, what happens is, if something wobbles out of line to the point that it sets a code, right? In other words, it's reached the top of its adaptive limit, or it's basically got a situation where it does the gear ratios not matching what gear it's supposed to be in, or something like that. It's basically going to take a snapshot of about 10 different parameters. It varies. It may not be just 10. But, you know, it's usually like engine speed, engine temperature, fuel trims, a whole bunch of stuff, and it's going to freeze that at the moment when that code was set. See, so if you look at that, if you pull it up, you can basically tell how fast they were driving, how warm the engine was, what the engine load was. I mean, it's giving you a bunch of stuff so that you can try to duplicate that set of circumstances and see if you can get it to act up at that same temperature, speed, load, and all that kind of stuff. And the DRB3 takes it beyond that to the similar conditions window. And what the similar conditions window is, this code was set, it interpolates that for you. That code was set so that you would know what was going on when it happened, so you could try to duplicate it at that same time. See, it's really important that you're able to duplicate it. That's the point. But anyway, I sort of got off. But that's what I mean. I got off on a rabbit trail, but it's an important rabbit trail. You know what I'm saying? We didn't basically go see something we shouldn't have. It's real good stuff. Which component is affected when a PCM is flashed or reprogrammed?
EEPROM.
Okay, and what does EEPROM stand for?
I don't remember. I know it's
Some here right here.
random memory, but I don't remember what the EE is.
Well, it's erasable. Basically, it's programmable, erasable, programmable, read-only memory. And you know how it does that? The reflasher juices that EEPROM up to like 18 volts. And when the voltage goes above a certain level, that thing's wiped. And then your flasher rewrites that code, basically. And so that's basically going on there. What sensor is used to determine the engine load?
RPM.
Huh?
I'm just
How can-
playing.
how can
I know,
RPM,
I know,
you know?
I thought about that.
Can't
ECT.
ECT, engine cooling temperature?
No, that's not engine load.
Map sensor, isn't it?
Map,
So,
manifold absolute pressure,
that's map.
or PM. That's about as funny as a screen door in a battleship.
I wanted to
Okay.
see if you were
That
paying
is fun.
attention.
Yeah. All right. Which term describes the speed of data transmission? How many computer geeks we got in here? Alex, are you a computer geek? The speed, how fast is it talking? It's going to be baud rate, basically. Yeah. Y'all didn't read these chapters? What happened here? You know you're going to have, these are just a few of the questions that are available from that chapter. I'm probably going to start with some of them that you've never seen when I build the final. You know what I mean? Okay, that's all right. That's okay. You'll have to dig through your book. That's all. You'll dig. That's right. Okay, so we need serious chapter readers. Now, if Lundy was here, he would have read the chapter. Where's Lundy at, by the way?
He jumped in a car.
Huh?
He jumped in a car with somebody and haven't seen him.
Oh, this could be a bad thing. Oh, my goodness. We might get a ransom demand. Okay. All right. Serial data is data that is transmitted by what? Serial data is transmitted by what?
Series of rapidly charging voltage samples.
Charging?
Changing.
changing voltage signals. Okay. Here's the thing about this. What's the difference between serial and parallel interface? If I said something was serial interface, or if I said it was parallel interface, what would be the difference?
It's,
Parallel is the same at all times, and serial is where it keeps going up. Right? It goes up in like
You're,
the
cause
pattern.
you're even confusing me. Okay.
Success.
And cereal is just only cereal.
You guys have looked at the back of a computer, right? Okay, you looked at the back of a computer, you know where your, the printer used to plug in?
yeah,
You had like a 25 pin connector,
right.
remember that? That was a parallel interface connector because it had 25 wires coming out of it. It had a whole bunch of different roads for traffic to travel on, right? When stuff was slower, you had to do that. So the other port, the little square one that you have, the little square USB port, what does USB stand for?
And I noticed,
Universal storage.
Serial bus.
Cereal bus.
And basically, it's got all this data that comes out over how many wires? 2 wires. There's 4 wires in there. 2 of them are power. One of them's power and one's ground. And the other 2 are basically your serial bus. Okay, so the serial interface. Now, right now, she's troubleshooting a no start on that Neon.
Yes, I am.
And when you disconnect that engine controller, how many wires are you seeing? How many now? It's like 60 pins, isn't
Yeah,
it?
it's like 50.
Okay, that is pretty much everything is hardwired into that computer. All of your sensors, you got powers, grounds, you got stuff coming and going, but it's got every one of them's got their own wire, right? That's parallel interface. But your scan tool is talking over how many wires. The maximum number of wires the scan tool is talking over on a particular bus is what? 2. It can be a 1 wire. If it's a 1 wire, it's heavy duty serial. Because everything's having to come down that same wire. And how in the Sam Hill can I plug in and get stuff on 2 wires? I plug it on 2 wires and I'm reading all this data. You got a whole list of PIDs there. And it's just coming on 2 wires. Basically. It's like cars headed down a 4-lane highway. When you got that bus going all over the car, you got several different buses, in the car usually. And when that bus is going all over the car, every bit of that data is going to every module on that bus. But the modules are smart enough to know which data they need and which data they don't. So it ignores the data it doesn't want, and it reads the data it does. You got? And this is not the kind of thing that a backyard grease monkey needs, knows when he's out there working on his, 350 Chevrolet. You have to actually have moved up the food chain a little bit to get to where you can understand this well enough to fix it. Now, if you see Adam in here drawing this stuff on the board, you can tell he's been there. You know what I'm saying? He got that done in a dealership, and when the bus won't talk, he can dig out his stuff and tell you why that bus won't talk and make it start talking again. Shorts, opens, terminating resistors that are, compromised in the controllers, that kind of thing. There's all kinds of ways to be able to find those buses. It's not simple electronics, as far as simple automotive electrical, there's other stuff going on. Okay, I just wanted to give you guys a little heads up on it. A controller area network, or CAN vehicle network, allows communications at speeds of what? 125,000 to 1,000,000 bits per
I
second.
guess that's it.
125,000. Now the older buses basically operate in kilobits, right? And I was told in one of my automotive classes that I went to at a dealer, at the dealer school, the manufacturer school, that copper wire, they said, couldn't handle over about 41,000 bits per second. And that wasn't really very much, but I think they figured out the better way to do that. They said you had to go optic fiber if you went above that, but these copper wires are talking a lot faster now. A digital multimeter set to read ohms is connected across terminals 6 and 14 of the diagnostic link connector, data link connector, excuse me. The meter reads 60 ohms with the key off. What does that mean? Key off, you got 60 ohms, right? Number 12, what is that? Is it a bad UART output, a normal condition, a CAN bus shorted to ground, or the headlights are off? Ding, 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 ding. 60 ohms is a normal condition. If you've got one that won't talk and you're reading nothing, or you're reading 20 ohms, you've either got something shorted or something open. See how useful that is to understand that? I like to disconnect the battery when I'm checking it. They don't say anything about that on that question. Low-speed Class A networks operate at less than how many bits per second?
2,000.
Please. 10,000. We're talking fast, man. Technician A says that module communications networks are used to reduce the number of wires in a vehicle. Technician B says communications network is used to share data from sensors, which can be used by many different modules. Everybody like that answer? We got both of them. Let's see, both of them. Okay, some CAN systems use pin number blank and blank in the DLC to communicate with the scan tool. Alex, do you know?
16.
You read the chapter?
It's deep. 6 and 14.
Huh? 6 and 14. We just got through talking about that right up, didn't we? The computer will automatically clear a diagnostic trouble code if there are no additional detected faults after what?
So you said they're true.
Got it?
They can have-
Anybody know? 40 consecutive warm-up cycles. One time, many years ago, I mentioned this one time, I think I talked about this when we were in automotive electronics. I had this Jeep,
What is it?
and this lady says, when I drive about 150 miles, my Jeep starts cutting up and bucking and snorting and going crazy. So I plugged in a recorder that we had that was for that purpose. It was, I call it a co-pilot, and I gave her this button to push. And I said, you drive that thing, and the next time this does this, I want you to push that button, make me a recording. So she came back in there a few days later. She said, I made your recording. So I pulled the recording up and loaded it into the MDS and did all that. And so looked up, and I said, when I looked at what was going on, I said, that engine controller going south. Whenever it gets good and hot, it's dropping some signals. It's not, processing right. So I got an engine controller ordered, put it on there. Went in there plugged in my DRB, went in there because she had vehicle theft security system and you had to turn that on. When you turn it on though, you cannot turn it off. So if you have to turn it on, you better make darn sure that it's equipped with it, because if you turn it on and it's not equipped with it, it will not start. I went there, made sure it was equipped with it. Little red light come on the dash and all that, so it was slightly different from the PATS, but it was a self-security system. You know the difference between perimeter anti-theft and passive anti-theft? Anybody know?
Permanent, you said?
Perimeter anti-theft or passive anti-theft? Perimeter anti-theft keeps them from stealing the stuff out of the car. Passive anti-theft keeps them from stealing the car. Got me? In other words, if you open the door and it's set, whoop, 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 passive anti-theft, it just won't start unless it reads that code and that key. Got it? All right, so anyway, let me tell you the rest of this story because it's important. So I plug this thing in, this engine controller in, and I crank it up. Everything seems fine. I put it, I take a little short test drive on it because I'm not going to drive at 150 miles. I'm sorry. I said, well, put it out there. The lady takes it home. She's back the next morning. She says, the little red light that tells me my anti-theft is working doesn't work. I said, well, I turned the daggone thing on. So I called the Chrysler hotline because I didn't see anything in the literature about it. Chrysler hotline, they're him-hawing around, they're scratching their heads. They said, I tell you what, update your, plug your DRB3 into the MDS and update it to level 51 or whatever, the next software level. So I did that. And then I went back into the screen where I was supposed to look at my vehicle theft, and they took that away from me on that update. What? Now my scan tool is where I can't even go in to do it. What's the matter with you guys? I need to talk to somebody else because y'all ain't really helping me. So they put me up there, and this lady got on the phone. And she says, tell me what your problem is. I said, well, I changed the engine controller and, blah, blah. She said, how many times has it been started? I went into the DRB3. It says it's been started 12 times since I changed the controller. She said, started 8 more times. So I started it, switched it off. Started it, and that counter kept going up. She said, when you get to 20 times, that thing will wake up. And I got to the 20th start, boom, that light came on, everything was fine. Well, see, that would have fixed itself over time, but that lady was noticing things. The reason they have it like that is when they're cranking it and fooling with it on the assembly line, they want to wind up with a doggone thing giving trouble and alarms going off and all that kind of stuff. They've got programmed enough starts in there so that on the assembly line when they're working on it, apparently they won't have issues with it because of the theft security system. You got me? That make any sense? They don't want horns honking and all that kind of junk going on in the vehicle that won't start. All right. So basically what I was getting at is these things typically use a counter. This is this 40 consecutive warm-up cycles we were just talking about. That's what that's all about, right? Okay, let's see. What number are we on? A pending code is set when a fault is detected on what?
Is this the first fault of a two-trip?
A pending code is one that hasn't turned on the light yet, but it's coming. In other words, basically it's giving it another chance. It's saying, see, one of the things they're wanting to do, they gotta have a check engine light by federal law, right? But they don't want it just popping on every time some little something wobbles this way or that. So what they do is they say, well, if it goes out of line this time, we're going to store a pending code, but we're not going to turn on the light unless it happens again. When it happens again, they know this is definitely a problem, and so we're going to turn the light on. So basically, that's what's going on there. That's basically the pending, the first of a two-fault trip failure. That's number 17. That's going to be C. A generic scan tool can access the same freeze frame information as an enhanced original equipment manufacturer scan tool.
False.
That's not true. You can't do that. Now, I will tell you this, some generic scan tools can get a little bit more information than others, if you tell them what you're working on, but they won't be the same as enhanced. And there are 2 rooms in that engine controller. You may clear the codes out of one room and there'll still be codes in the other. I've seen that a time or two. It don't happen very often. I've seen a misfire code that we cleared out of the enhanced room and the light was still on and we had to go into the OBD2 room to clear it out of there. So there's 2 rooms in an engine controller. The OBD2 room will not lie to you. The enhanced room will. If you've got an open coolant sensor, for instance, the one in the OBD2 room will tell you it's 40 below, which ain't right, unless you're freezing your fanny off and you're in Siberia. The other one, the enhanced room, if you unplug a coolant sensor, it may substitute another value and lie to you about what the value is. So if it's about 100 degrees outside and you unplug a sensor, it may tell you, it's going to pick something that it can use that will kind of work, you see. So if you always go into your OBD2 room and then go into the enhanced room, you typically you're getting a big picture that way is what I'm getting at. Which term, the mill is turned off when? Malfunction. Okay, it's going to be either the vehicle's driven 3 consecutive trips with warm-up cycle meets all set conditions without the PCM detecting any faults. There are certain conditions and parameters that have to be met before it even checks something. Like the catalytic converter, it cannot check the catalytic converter until it's hit road speed and it's cruised for a little bit. And it's got a timer. How long have I cruised at this speed? How warm is everything? Is a test on the catalytic converter at this point valid? If it's not valid, it's not going to do a test because they don't want it throwing all kinds of renegade codes that sends the mechanics chasing their tails. You got me? All right. So any of the above is right. Codes are cleared with the scan tool one. Which term describes a set of conditions required to allow each monitor to run? Somebody be creative. What do you got? It's not mill. It's not flowchart. It's not comprehensive component monitor. It is enabling criteria. Comprehensive component monitor is always watching these particular components, right? In other words, no condition has to be met for it to tell you if the TP sensor is going out of range, right? But basically, what if somebody has got a thermostat that's not closing, but they don't ever give it time to warm up anyway? Like mom and pop. Like let's say they live about from here to the stop sign from the store. They go to the store, and Grandpa sits down there and he plays checkers for a while, and then he comes back to the house. And he ain't driving more than 400, 500, 600 yards. He's not driving it long enough for it to warm up anyway. So it ain't gonna set a PO 128 until it's run for enough time to where it knows. You see what I'm saying? Well, a comprehensive components monitor, if a rat gets up in there in Grandpa's hood and chews his throttle position sensor wire in 2, it's gonna instantly know there's a problem there. It doesn't have to have an enabling criteria for that. So see, you gotta kind of weigh everything out like that. All right. Let's see, a customer states her malfunction indicator light is blinking. Technician A says this condition may damage the catalytic converter if the customer continues driving. Technician B says the freeze frame data should be stored. Which technician is correct? That is a Charlie. That is a Charlie. Yep, that's right. It may damage the catalytic converter if you've got a misfire. Most of your engine controllers nowadays, if you've got a misfire, it's going to shut off that fuel injector. Under what conditions does shutting off the fuel injector not do any good? I'm talking about misfire conditions. What if the daggum fuel injector was leaking? What if it was dripping fuel? Because it mechanically couldn't close. You see? You keep driving it with a check engine, and most of the time that's not going to be the case. But if you've lost your spark and it starts skipping, or if maybe all of your little holes, but one of them going to your EGR is plugged up, and it's getting a lot of EGR in that cylinder, causing it to misfire. In other words, if all the rest of them ain't getting no EGR and it's getting it all, it'll misfire on that cylinder, bop, 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 and it'll ping, ping. You ever seen yours flash on your Mustang? You will before you leave today. Okay, let me see here. Well, I got to get to his Mustang to make it happen, though. Okay, so all right. OBD2 requires the PCM to detect faults, allowing emissions that exceed how many times the FTP standard?
2.
No,
Excuse me.
1.5.
1.5. All of these OBD2 require. All of these are OBD2 requirements except what? How can it do that? Tell the technician what's wrong with the vehicle. And you remember the OBD3 situation I put in my digital Superman book, right? That was basically one of those things where he was made to go get the car fixed. Yeah, it's kind of going there. The Ford Star satellite's talking to the computer on the car. It sees that thing and it says, you got a problem, you're going to go to a dealership and you're going to go there now, or we'll have your firstborn in an order of fries, right? Okay. Right here, let's see. Which OBD2 term describes the check engine light?
MIL.
Why couldn't they call it the CEL? But that's not a OBD2 term, is it? Not according to the 1930 regulation. Okay, let's look at parameter. Did you know the MIL is covered for 8 years or 80,000 miles on some cars? All right. Parameter identification display is included in which OBD2 generic mode? Do you know your modes, y'all? You know your modes. That's mode 1. There's a bunch of different modes. Okay, before we actually get to final exam, you need to have all your modes memorized. Got me? Need to know which mode's what. Then you see on your scan tool, it talks about this mode and that mode and the other mode. Some of them's a clear code, some of them freeze frame, some of them's this, that, and the other. Mode 6 data, gives you the parameters and all that kind of stuff, tell you what's about to fail. Good stuff.
I don't think we went past mode 6, did we?
Huh? You ever do mode 6?
I don't think we went, mode 6 was something special, I think.
Yeah, basically it was. It's pretty special. But you gotta know how to look at it.
Yeah.
All right, so mode data is good. Mode data is good as our friend, mode 6 data. Okay, technician A says disconnecting the battery is the best way to erase stored DTCs, OBD2 DTCs. Technician B states disconnecting the battery may not erase stored freeze frame data. Who's right about that? B is right about that. Usually it will, but it may not. Technician A says a loose fuel cap could illuminate the mill. Technician B says a loose fuel cap could cause a B0320 diagnostic trouble code. Oh, goodness gracious, no. That ain't no B0320. Where'd that come from? Who said that?
Oh,
Yeah, that's a P0455 or something like that. Okay,
so A is right.
yeah. Remember I told you, Roger told me, he said, I'll buy your lunch if we go check this Lincoln check engine light. And I went over and checked it at 455 and I put the gas cap back on. And I said, all right, you owe me a lunch. He goes, no, it's still 2 minutes to 12. I ain't buying your lunch. I fixed it in 3 minutes, All right, so that was funny. I said, hey, man, deal's a deal. A vehicle has a stored DTC for oxygen sensor fault. This could cause what? Ding, ding,
Catalyst monitor.
ding, ding. It has a stored DTC. What? Come on, guys, look at those answers.
D.
What did you say?
It's third year.
D.
You said D, didn't you?
Yeah.
Good deal. That's what exactly we need to see. A monitor that has not run to completion will indicate what on the scan tool?
B.
It's going to be incomplete, isn't it?
Yeah.
Which first digit code indicates a network fault? Which first digit code indicates a network fault?
B.
Network fault is indicated by what?
B. What? D.
What about U? U is a network code. Now, if I was setting this up, I would make it an N code. I don't know why they made it a U code. Maybe somebody does. I'm sure I'll probably get a phone call or an email from somebody about that. Okay, that's all. Is everybody happy? Didn't take us long to do this?
I have a double sign.
Right?